topics in AWS. All of us should have a good understanding of VPC, how VPC works, right? I mean, how do you provision a new VPC and how do you segregate workloads within the VPC, right? And as part of that, what are security groups, NACLs, right? And how the CIDR range, the IP addressing works within VPC, right? So these are certain topics, key topics that we learned over the last couple of weeks, right? Which form the foundation for our AWS cloud learning path. Okay, so now what I'm going to do today is, let's all of you did a few hands-on exercises with provisioning EC2 instances and provisioning multiple EC2 instances, and also learning how natting works within AWS, right? Using a NAT instance, NAT gateway, and so on and so forth, right? So now what we will do today is, today we will spend some time on the other features of EC2. Okay, I'm going to show you some of those other features of EC2. So where you learn what each and every configuration while launching an EC2 instance means, and also EBS, right? EBS is also another important topic. I'm going to cover that today because till now if you remember, if you recall, I would have asked you to keep the settings default, correct? For while provisioning an EC2 instance, except for a few steps in the wizard, right? Rest of the steps you would have just kept it by default, the default settings, right? So now we are going to connect to one of those and then see how it works. What if you change a setting, right? What each setting refers to, and what each setting would basically mean. And also we'll cover about EBS. EBS is a storage. So today I'm going to introduce you to EBS, which is one of the storage types in AWS, which provides you a hard disk within your EC2 instance, right? Like how all of us have hard disks within our laptops or desktops, right? So that way, EBS provides a hard disk for a local disk for, I wouldn't say local, but it's a disk, right? It's a disk which is presented to the EC2 instance, so that EC2 instance can boot from that, and EC2 instance can store all its operating system files or any other files that it needs. It can store it as part of the EBS volume. Okay, so let's get bootstrapped. Just give me a second. Let me pull up my account. Okay, I'm just going to share my screen. Okay, all right. So I'm in my AWS account. I'll actually go to North Virginia or Mumbai. Mumbai is our region. So I'll just go to Mumbai. Okay, so that's the first thing that you should always look at when you log into the AWS Management Console. Navigate to the right region where you have deployed your workloads, right? Or where you have deployed your applications or your servers or storage or whatever it is. Okay, so go there, then click on EC2. Okay, so we are in EC2. Just click on instances. So I have two instances running, right? So a private instance and the public instance. I just started it. Okay, all right. So now all of us are familiar with how this interface looks like, right? And when you click on a instance, what are the details that it shows in the bottom, right? Such as your instance details, instance ID, public IPv4, private IPv4 address, right? And you all know the difference between public and private, right? What does a public IPv4 address mean? What does a private address mean, right? And also you know what is the instance state, right? And you know what is the instance type? It's t2.micro, right? And you also know what is the AMI on which the instance was built. AMI is nothing but Amazon machine image. In fact, if you recall, that is the first thing that I would have taught you when we started EC2. It's nothing but a image file which will give you the operating system that you need, right? Either it is a Amazon Linux or Red Hat Enterprise Linux or CentOS or Windows. Okay, so that's basically the AMI. And more important, we have a key pair, right? So key pair is nothing but it's a password to log into your EC2 instance. Okay, so that's a key pair. Yeah. So these are the things that we really looked at. And then if you go to the next tab, security tab, out here you have a security group associated with it, right? What is a security group? A security group is a instance firewall, correct? It's an instance firewall. I'll go back to our good old diagram. Yeah. Security group is around the EC2 instance, right? So around the EC2 instance, it basically provides a virtual firewall to your EC2 instance where you have multiple rules within your security group, ports, protocols, and source, right? So there are two types of rules that are there: inbound and outbound. Inbound is when uh, when a external system needs to talk to your EC2 instance, then it becomes inbound for your EC2 instance. When your EC2 instance needs to talk to an external system, that becomes an outbound for your EC2 instance, right? So from that perspective, it's an inbound, and where you have inbound security group rules, outbound security group rules, and you have inbound and outbound, which is basically a request and response. Okay, and I also gave you examples of how you can modify the security groups in real time. Like for example, if you remove the port 22 in your security group, then you will lose connection immediately to your EC2 instance, right? We saw all of this. So that's basically the security group, and you can see all the security groups here. Okay. So then if you go to networking, again, networking is where you get your VPC mapping, right? Which VPC your EC2 instance belongs to. Within VPC, which subnet it belongs to, right? Because that's important, right? When you provision an EC2 instance, it has to sit within a subnet, the orange box, right? It has to sit within a subnet. So you know which subnet it belongs to, correct? And what is the availability zone that that subnet belongs to. In turn, a subnet belongs to an availability zone, right? Whether it is, if it is Mumbai, it is AP South 1A or 1B or 1C. There are 3 availability zones in Mumbai, right? So that's how it belongs to. And network interface is something I'll just explain to you shortly. So then you have storage, right? So storage is the underlying EBS volume that is attached to the EC2 instance. EBS volume is nothing but the disk, the hard disk associated with the EC2 instance. Okay, so you have your block device storage associated with your EC2 instance, right? And I'll explain this shortly. But if you see, that's called EBS, right? So if you want to learn more about EBS, as usual, go to the EBS homepage through Googling. So then you go to resources, right? So then you click on user guide. Yeah, it's going to take you to the EBS homepage. Okay, so this is where you can find details about these EBS. In fact, this is the EC2's homepage. In EC2's homepage, you have got a subsection under storage called EBS. Okay, but this is the EC2's homepage. In fact, I will give you this. You can bookmark this EC2. Yeah, so you just bookmark this one. Just pinging you in the chat. Okay, so I've just pinged you in the chat. And just bookmark it. Keep it handy. This is your Bible. So you have to look at it. You have to look up to this every time you need some help or you need some. So here, what we're going to do specifically is we'll go to EBS. So let's get started with EBS, right? So what is an EBS? EBS is basically uh, the hard disk associated with your EC2 instance, right? Like how we have got a hard disk, which is either a magnetic hard disk or which is either a SSD hard disk, right? So in fact, I spoke about SSD sometime back, right? And I believe some of you as well answered what an SSD is, right? And many of you said you guys have SSDs in your home computers, in your home laptops or desktops. Okay, but yeah, I'll explain more about what an SSD is, right, and how EC2 uses SSD, or how EBS uses SSD. Okay, so EBS, what does EBS stands for? EBS stands for Elastic Block Store. Okay, as the name says, store is storage. It's a storage, correct? So where it stores the files and it stores the operating system, it stores everything, right? Without storage, your computer is useless, right? Your computer will never be able to boot up without a storage. So storage is an essential component of your compute system, right? So Amazon Elastic Block Store provides block level storage volumes for use with EC2 instances, right? So now you might be wondering, what does block mean, right? What is block? See, there are in the storage world or in the storage industry, there are different types of storages that are available. Okay. Uh, Typically, if you see there are interfaces that various different systems offer, right, which allows you to store objects or store files in a different fashion, right? So from that standpoint, always block storage means, that is the underlying disk associated with your EC2 instance or your computer. Okay. Let me just show you an example. Okay. So we've got your Windows 10 or whatever Windows system, right? If you just go open my computer, right, this PC. So this PC has got a C drive attached to it, correct? A C drive is present as part of your computer. Like similarly, you will have multiple D drive, E drive, F drive, and all that, so on and so forth. Correct. So now, if you see, the C drive is called as a block store. Okay, because a block of about 30 GB. This is 30 GB, 29.9 GB. A block of about 30 GB is allocated to my computer, right? And it is able to read and write files from my 30 GB, right? So in this case, this whole 30 GB is considered as one single block. Okay, because it is stored as a complete block, this thing, right? So now underlying, if you see, there are various different file systems that have evolved over a period of time. Okay. I'm sure, most of you would have come across file systems in your computer science subjects, right? So there are file systems called NTFS, which is Windows's file system, right? And then you have file system called NFS, network file system, right? And then you have various different file systems that Linux uses, right? Linux again uses a very, very popular file system, right? So there are multiple different file systems that, FAT is again another file system, right? FAT32. Okay. So now what happens is in a block file system, there are blocks that are created as part of the file system. The block size can be, whatever 1024 KB or whatever it is, right? So that's why, you have a block associated with your file system. Okay, so that's why it's called block file system. Now there are other types of file systems that are there where you store files just as a file, right? So where every transaction just goes as a single file and comes back. Whereas in a block file system, it is not a file. It's not at a file level. It is at the block level, where the block is whatever size the block is. It basically reads and writes from every block. A file can be stored in that block file system. If the file is huge, then that file will be split into multiple blocks and it will be stored. Okay. So now when the operating system retrieves that file, it has to read those multiple blocks, reconstruct the file, and then give it back to you. Okay. That's how the block file system works. Whereas you take other file systems, where you're just storing files like a shared directory, right? Or even cloud-based file systems where like Google Drive or S3, right? Amazon S3, Google Drive, these are all providing a direct file level access, right? Where you don't have to worry about having another interface to convert those blocks and reconstruct the file and give it back to you, correct? So there, you straight away get access to the file, provided you have the right credentials or your user account has got access to the file, and then you'll be able to read the file and you'll be able to write a new file to the file system directly, right? So those are called object file systems, or object storage, or they're called file systems. File system, file level. It basically deals at a file level or an object level. Okay. So now that's where, if you see, and also there's something called NFS, network file system, right? Again, network file system is common in Linux, right? So where network file system provides a ability to attach it to multiple different servers, or it is present as a file system on the network, right? Anybody who wants to access a file, they just go over network, reach their destination, they can take that file from there, provided they have access to it. That's why it's called network file system, right? And then there's something called NAS, network attached storage. In fact, these days, even NAS is available for even for home, right? So where
Sorry
you
for
get a,
disturbing. Sir,
yeah, yeah,
are you sharing another screen, sir?
yes. Are you able to see the Windows machine?
It's a local disk, that
Ah,
only.
that's okay. Yeah, I'm only sharing that. I'm only talking right now. I'm not showing you anything on screen.
Okay, sir. Okay, sir. Thank you, sir.
Okay. Yeah, sure. And so I was talking about NAS, right? And network attached storage. So where, um, what I'm trying to tell you is, I mean, I'm just trying to briefly, at a very high level, introduce you to the various different storage and file system classes, right? So that you understand the difference between each one of those, right? And then, it is probably an additional thing, which you can learn. Okay. It is not 100% necessary, but it'll be good if you have this knowledge, additional knowledge. So that's the reason, I'm just spending a few minutes. I'm being vocal about explaining some of these concepts. I can give you some links also to that at the end of this session so that you can read through those. So NAS is again another network attached storage, right? So where uh, you have even for home networks, right? So where you have a router or your modem, correct? Wi-Fi router. So in fact, there is 1 TB or a 2 TB NAS box that you can get from Amazon, right? Which you just take it, connect it uh, to your router using a LAN cable, or you can connect it to the router using Wi-Fi also, right? So that's a storage device which is available in your home, right? Anybody who wants to store files, they can actually store files into that. Okay, anybody who is connected to the network can actually log into that NAS device and then read and write files from that. It's like a common storage for everybody, all your family members, okay, all your friends that you have, right? I mean, if a group of friends are actually sharing an apartment and they've got a local network, a home network, home internet, you can buy a small NAS device, put it there, and then you can share files with everybody, right? So that's again, like that's a very small rudimentary example that I'm giving, but again, look at large companies or large enterprises who store terabytes of data, petabytes of data, right? So in such cases, obviously the requirements will be quite sophisticated and requirements will be quite vast, and the solution that needs to fulfill those requirements will have to be a robust solution. Okay, that's called NAS. And SAN. Okay, SAN is something called storage area network. Okay, so now we've got um, a home computer, right? All of you have got a home computer, a laptop or a desktop, right? So now within your laptop, you've got a local hard disk attached to it. Similarly, on the desktop, you have a local hard disk attached to it, right? But that is not the case when it comes to data centers. Okay, in data centers, uh, there won't be a local disk attached to the server, right? In fact, I showed you about how a data center would look like and how racks are there, and within each rack you have got multiple servers racked and stacked and connected to the network, correct? So now each server is probably about whatever 16 core and 64 GB RAM, or whatever 64 core 256 GB RAM, right? On top of it, your EC2 instance gets provisioned through virtualization, right? So that's how your EC2 instance gets provisioned, right? So now usually in data centers, the way it works is you will not have any storage attached to your physical server. Of course, there will be a storage. It comes by default. It comes with some local hard disk, but usually that is not used much. Okay, rather because okay, I'll tell you why. Okay, I'll come to the why part a bit later. Rather, what will happen is there is going to be a separate set of arrays servers which are only dedicated for storage and which have got various different storage associated with it. So now that storage is presented to the servers in the form of storage virtualization. Okay, so now that's where, if you see, that's called SAN. It's called storage area network, where you have a separate array or separate rack of servers, or which is only dedicated for storage, right? And that is a common pool of storage which is available. So now when you provision an EC2 instance, what happens is when you ask for 30 GB, in this case, I've asked for 30 GB of C drive, correct? So that 30 GB of C drive will get provisioned from my SAN, and then it will be attached to my server. It will be attached to my EC2 instance that I provision. Okay, that is called SAN. Okay, so now if you want to read more about SAN, I'll just point you to certain. Okay, a storage area network is a dedicated high-speed network or sub-network that interconnects and presents shared pool of storage devices to multiple servers. Okay, I'll just show you an, yeah. So if you see this diagram, yeah, yeah. So if you see this diagram, these are the servers that are present in your racks, right? So where you have the racks, each rack has got multiple servers. Now, if you see, the hard disk within the server is not used, okay? They are not typically used, but rather there will be a separate setup similar to what you have servers. There will be something called storage, okay, which is a array of storage. Okay, so now what that array of storage does is it basically presents block storage to your servers, right? And now this array of storage is connected to your servers through a high-speed fiber channel. Okay, what is fiber channel? Fiber optic cables. Okay, those fiber optic cables are so fast and so efficient that it actually goes over network. Okay, but it will give a notion to the server that, you know, the storage which is present is actually connected to the local motherboard, right? Usually what happens now, in a motherboard you have got a CPU, memory, and you also have your SCSI interface. It's called SCSI interface, iSCSI interface, right? Where you go and plug your hard disk, correct? And then what happens is everything is within one single motherboard. The communication happens very fast within the motherboard, correct? I mean, when the system needs to boot up, or when a CPU needs to take some files from your hard disk, it goes to the motherboard. Uh, Motherboard will basically, the processor would process the instructions. It will go to the motherboard. Motherboard would route the traffic to the iSCSI interface. iSCSI interface would in turn go to the hard disk. It will ask the hard disk to retrieve so and so file from its storage, and then the hard disk will rotate, or if it is an SSD will just do a lookup. It will get the file again. It will, through the motherboard, it will send it back to CPU, and CPU will process that file, and CPU will present it to the user in whatever way that the user wants. Correct? That's what happens. Everything happens within the motherboard, right? But here in this case, it is not attached to a single computer. Right? Your storage is not attached in the single computer, but rather the storage is present in the network. Okay, so over the network, it has to go get all this. But that network is so fast; it's a dedicated fiber channel over Ethernet. Okay, it is so fast that it will not give you any performance degradation. It will be as good as your hard disk is attached to your local motherboard. That is the notion that it will give. That is called SAN. Okay, it's called storage area network. Storage SANs provide shared storage over a dedicated network, block storage and enhanced speed, but they are a slightly expensive option. But usually what happens is the reason why we do this, why enterprises or why data centers do it this way is, see, you all have to understand it very clearly, right? When you are dealing with uh, a huge setup, right? When you're dealing with a huge setup, a big data center, which spans across multiple acres, it is it is not just possible to uh, do things manually, correct? And you also need to have resiliency, and you also need to have enough backup to uh, compensate any underlying hardware failure that you might have, because all these are hardware. At the end of the day, they may fail because they are all parts. Anything can happen to it. I mean, there could be issues with that, and always hardware can fail. Like, it's like a car, right? I mean, when I buy a car or a two-wheeler, I may have hardware issues anytime, correct? I may have problems with my clutch. I may have problems with my brake. I may have problems with my engine, right? So then what you do is you go to the workshop and then get it fixed, correct? So similarly, even on servers, there can be problems with the hardware device anytime, right? So now, in order to now when assume, when you're using the local storage of a server, which is locally attached to that server, right? And suddenly the hard disk crashes. Okay, now at home, when our hard disk crashes, what will we do? Right? I mean, if you have a backup, then it's fine, you're safe. But if you don't have backup, you lose all the data, correct? So, but here in this case, in data centers or when in cloud service providers, the way they do is, because they ensure that they're providing a service level to their customers in terms of storing and managing the data, correct? So from that perspective, what happens is, there are multiple copies of the data which is stored, right? And the multiple copies of uh, uh, the block which is stored. So even if there is redundancy built in the SAN, okay. Now, if you store everything in one single computer, and if that computer fails, if there is some issue with that, then you lose the entire data. But rather, if you store your data in an array like this, where a copy of the file is present here, same copy of the file is present here, and it's also present here. In case if this goes down, your SAN will take care of pulling the file from here instead of this. Okay, so that way you have redundancy. But if you rely on one single computer to store all your files, then you don't have redundancy and you don't have resiliency to failures. Okay, so that's the reason why SAN is a very, very important concept. Okay, for now you understand that SAN is nothing but it is a set of storage arrays, okay, which is again part of the network. Now, when a server gets provisioned, when an EC2 instance gets provisioned, the required storage is presented from your storage array to your EC2 instance, right? So even if your underlying hardware of your EC2 instance, like your compute, goes down, your storage still is there. Your underlying volume is still present. You can quickly provision one more EC2 instance, attach the same volume to that other EC2 instance, and then continue your uh, application, right? Continue your server. So that is the advantage. Okay. So from that standpoint, what happens is, you see the C drive. C drive is attached to this EC2 instance, right? When I say this EC2 instance, just manage. Okay. You see this computer, right? So this server named ECZ, EC2 AMAZ, Okay, so it's basically attached to this computer, okay, which has got I think two processors and 8 GB RAM in this, right? It is a Windows Server 2019. Okay, so now it is attached to it, but it is not though it is attached to this, it is not physically present within that server, within that physical box where this EC2 instance is present. Okay, it is virtually attached to this. Okay, it's virtually attached because it's all about virtualization, right? This is where storage virtualization plays a major role. Okay, so now you know what happens is when Amazon stores it, Amazon actually stores multiple copies of this, so that way the 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 storage array where the storage device where the C drive is stored, even if that goes bad, you have one more copy of it available, so that you can quickly restore it from there and bring it back online. Okay, that is the advantage of going with the storage virtualization. So now let's go back to EBS. So EBS is basically a SAN. It's a SAN on AWS, which provides a block storage to your EC2 instances. EC2 instances are nothing but servers, virtual machines. Okay, I want you to understand that it's a SAN. At the end of the day, it's a SAN. So that when you face interviews, they may ask they may ask you, what is the underlying storage type for EC2 instance. Then you will happily say that it's EBS because I was taught that EBS is an elastic block store. Okay, but if I don't teach you what EBS is, then the next question that may come from your interviewer is, okay, tell me what EBS is. What type of storage is EBS is? Okay, so then you can confidently tell them that, okay, EBS is a SAN. At the end of the day, it's a storage area network. It's a SAN storage. It's a SAN storage. And from the SAN storage, a block of 30 GB or 60 GB or 100 GB is provisioned, and it is attached to my EC2 instance. Okay, the advantage of SAN is it is resilient, it is highly durable, and also it is fast, it is efficient. Okay, because SAN, NAS, these are all different types of storages. Okay, so that's where you should know that EBS is SAN, storage area network. Okay, EBS provides block level storage volumes for use with EC2 instances. EBS volumes behaves like raw unformatted block devices, right? Again, unformatted, correct? I mean, when initially when you buy a hard disk, right? I mean, a lot of you would have tried it at home, correct? Where you wanted to expand your storage capacity of your desktop, right? So then you would have bought off the shelf a hard disk, a Seagate 500 GB or a 1 TB hard disk. And when you connect that hard disk to your motherboard using your iSCSI interface, and then when you boot it up, by default, what will happen? You will see that second hard disk in your volume, right, in your disk manager. When you go to disk manager, you will see that second hard disk here. You will see this is disk 0. You will see a disk 1, and you will see that 500 GB as a raw unpartitioned device, correct? So this is basically called a block device. This is a block. Okay. So now you will then see that here. I mean, when you attach a new hard disk, a fresh hard disk which you buy from a store, then you attach it to your computer. Physically, you will see that here it is present as a raw volume here. Okay, then you have to right click on that, and then you have to say format. Okay, right now I can't do that, but you can say that. You can say right click, and then you say create a volume out of it, right? And then you will say format it as NTFS or FAT or whatever it is, correct? So that's how you do, right? How many of you have tried it? Nobody has tried it?
No. What interface into some other file systems?
No. you're adding a new hard disk to your computer.
Is it here
Right?
or
You mean partial disk, sir?
this
What do
VP
you mean
will
by
come?
partial disk?
Disk partitions.
No. What I'm asking is, have you bought a new hard disk and have you attached that hard disk to your computer anytime? Do you have experience doing that? A brand
Actually,
new
as an
hard disk.
external source, I have added it, but not through internal source.
Okay. Yeah, as an external hard disk, it's fine. That is, see, when you add it as an external hard disk, it's just a storage. It's a file level storage. It's not a block level
Yeah,
storage,
that's
right?
what I added.
That is a file level.
I tried it, but I couldn't get it. I screwed up my original disk. That's why I stopped it.
Okay. All right. Which hard disk you were using?
Seagate, sir.
Seagate. Okay. No. So usually, what you should do is there'll be multiple iSCSI interfaces in your motherboard. So you have to connect it to the second iSCSI interface. Don't touch your primary one. Let the primary boot disk be there. You attach it to the second iSCSI and then you boot it up. First go to the BIOS, and in BIOS you have to change the boot order. If your boot order has changed, then it will work. Okay. Anyways, coming back to the topic. So that's what happens now. It behaves like a raw unformatted block device, and then you can mount these volumes as devices on your instances, and then EBS volumes that are attached to an instance are exposed as storage volumes that persist independently from the life of the instance. Okay, that's very, very important. In fact, I will just do some whiteboarding. Elastic block store. Okay. I'll actually take this diagram only. Okay, I don't need any of these. I'll remove everything which has got NAT in it. I don't need any of these. Okay, I'll just keep this. Okay, so now I have an EC2 instance, right? And within the EC2 instance, I've got a storage, right? Usually storage is represented like this cylinder. Okay, so this is my EC2 instance and this is my underlying storage, which is probably C drive. Okay, so this is my C drive. Okay, it's attached to my EC2 instance. Okay, so it's attached to my EC2 instance. So now the C drive itself comes from a different physical server, correct? It's not attached physically to the server on which my EC2 instance is running, correct? That's where I was explaining about this SAN storage, right? So where SAN itself is a separate physical area which is connected through network to your server. Okay. So now what happens is when you have an EBS volume of say 80 GB, right? Let's say this is an EBS volume of 30 GB, let's say 30 GB. Okay. It's called a volume basically, right? So when you have an EBS volume of say 30 GB, this EBS volume of 30 GB is present in a separate physical server somewhere else, okay? And that is presented to your EC2 instance. Now, what happens when your EC2 instance crashes? Okay, you will still have your EBS volume present. It won't go away. Okay, if your EC2 instance crashes, you will still have your EBS volume. So now, if you have say one more EBS volume, right? This is your operating system. of 30 GB. Okay, so now I'm provisioning one more EBS volume, which is for data. I'm storing all my files and data into that. Okay, so that is D drive. That is D drive. It's again another 30 GB, or I will say 100 GB, because the operating system doesn't need so much, right? The operating system, I'll only allocate 30 GB, but I'll allocate more to store my data. So that is also connected as part of your EC2 instance, which is present as a D drive, right? So now for some reason, your EC2 instance has some issues, and then your operating system crashes. Okay, your operating system crashes, and your C drive gets corrupted. Okay, your C drive gets corrupted. Okay, so what happens is, or your EC2 instance goes down, right? Or your C drive gets corrupted. What will happen is your D drive is still intact. Okay, nothing happens to your D drive, because when you provision a new EC2 instance, right? Let's assume I have provisioned a new EC2 instance in another one that I've provisioned. I'll just provision that quickly. I provision another EC2 instance. What I can do is I can simply instead of attaching this to the instead of attaching this to this EC2 instance, I can attach it to this EC2 instance. So, and then I'll bring up my operating system. I'll be able to access my files here. Okay, that is the benefit of EBS, right? So that's the benefit of EBS, and where it is not dependent on the server where it is associated with. So that's why if you see, you can mount these volume devices on your instances. EBS volumes are attached to an instance, are exposed as storage volumes that persist independently from the life of the instance. In this case, if the life of this instance goes away, I can just quickly take this EBS volume, detach it from this, and attach it to my this instance. Okay, that's why they are independent persistence, independently from the life of the instance. You can create a file system on top of these volumes, or use them in any way you would use a block device, such as a hard drive. Okay, it is a hard drive. At the end of the day, it's a hard drive. And also you can dynamically change the configuration of the volume attached to an instance, right? I have 100 GB, suddenly I want another 100 GB. You can make this 200 GB. So it will scale, it will be elastic. Okay, Amazon recommends EBS for data that must be quickly accessible and requires long-term persistence. EBS volumes are particularly well suited for use as a storage, as a primary storage for file systems, databases, or for any applications that require fine granular updates and access to raw unformatted block level storage. Okay, Amazon EBS is well suited to both database style applications that rely on random reads and writes, and to throughput intensive applications that perform long continuous reads and writes. Okay, so now let's go into, now all of you understood what an EBS is at the end of the day, correct? It's nothing but a hard drive, but it's independent of the life of the instance. Even if your instance goes down, your EBS volume is still available. You can use your EBS volumes to basically detach it and attach it to a new EC2 instance, and your new EC2 instance can persist. Sorry, just give me a second. Okay, sorry. Okay. Okay, all right. So that's the idea. So let me just share my screen again. Okay, now let's do some hands-on with EBS. Okay. Before that, I'll just show you some differences in various different volume types. Okay. If you go to this EBS volume types, you can read about this here. It provides different volume types. It can either have an SSD. Okay, what is SSD? I told you about last time, about SSD last time. What is SSD? Can somebody explain? SSD. What is SSD? A lot of people answered last time saying that you have an SSD in your laptop. Where are those guys who answered last time?
This is a flash memory, sir.
No, it's not a memory. Memory is RAM. It's a flash storage.
Sir, it is a storage state, right? Storage device, sir.
Okay, so what it does?
I like a storage in computer.
Sir, like a pen drive. SSD card like a pen drive.
Like
not
Pen drive,
completely
mobile memory.
correct.
Mobile memory card.
Not completely true. Yeah, I mean it is something like that. Yeah, correct. But what it does?
It will make our system 10 times more faster.
So how does it make it faster?
system.
Yeah, so how does it make your system 10 times faster? What technology it uses?
It stores data on electronic chips.
Yeah, it stores data on electronic chips. Okay, then okay. So basically, if you take a look at the evolution of storage, right? Originally, I'm not sure how many of you have seen floppy drives. Have you ever seen a floppy drive? Floppy disk.
Yeah, we have seen, sir.
You've seen the small one or the big one? You've seen the small one or the big one?
Big one, sir. Big one.
Big one.
Okay.
When
Big
I'm
one,
schooling in
which
8th standard,
so when you say big
we
one,
used to,
what, the 5.5 inches or the 3.5 inches?
3.5 inches.
3.5. 3.5 is small. It's not big. See, big one is, in my school days, not in your school days. Okay. In my school days, I have used the big floppy drives, which is the 5.1/4. Okay, where you have it's like a cardboard. Within the cardboard, you have you'll have the magnetic disc. Okay, it's again like a film. It's like a film, right? So you insert that. Okay, it's about I think 2 MB or something. It provides 2 MB storage. That's it. Okay, I'll just sounds interesting actually. Floppy disk 5 point. Yeah. If you see this, so this one. In fact, I have a few like this. I'll show you sometime. I have to search for it. It should be there in my archives. I hope it is there. I have to search for it, but I'll show you sometime. But if you see this, right? So this is how it is inserted into the computer. Okay, this is how it is inserted into the computer, and where it's like a cardboard. It's like a not cardboard. It's like the chart paper that you have. No, it's something like that. It's a small plastic thing, very thin, very fragile, very thin. Okay, just insert it in, and then here you see a small opening here. Through that, the read write head will read and write from it. Okay, I don't know what is the capacity. Capacity is how much. It's actually 1 MB, right? It's actually, if you see, 1.44 MB. That is the capacity of it. Okay, so then came like 3.2, 3.5 inches, which is a smaller one. 3-point-inch capacity. That is about. It can go up to like 2.8 MB. Okay, again, it's an MBs only. You can't store more than few MBs. You can't store more than that. Okay, so now this one I still have these. I'll show it to you next time. This, a lot of you would have seen, 3.5 inches. I think it is not majorly in use these days. I mean, it's hard to find even a floppy drive attached to a computer these days. It is there. I'm not saying it is not there, but it's quite rare that you find that. So now what happens is, when you insert that, there is a magnetic film inside that, and that magnetic film gets positioned over the read write head. There will be a read write head on the computer, which will read from that using the magnetic drive, and then it will transmit the data to your CPU, and then memory will process it. Okay, so now what are the disadvantages of it? The disadvantages is, again, your hard disk, right, where you have your traditional hard disk, which is the magnetic hard disk like Seagate or anything of that sort. What that does is, that also does the same thing, right, where it has of course it has capacity is a lot more, and it can perform much better than your floppy drives, where it rotates at 5,000 rotations per minute, or 7,500 rotations per minute, or 15,000 rotations per minute. Okay, that is the speed at which it can rotate. Inside the drive will rotate. Okay, you'll have multiple drives stacked. Okay, small drives which will be stacked under each other, and it'll rotate, and then what will happen is, your read write head will position over the respective sector from where it has to read the data. Okay, and then it'll read the data, and then it'll send the data back. Same concept. Okay, but the problem with magnetic drive is that firstly, it is very mechanical in nature, right? So where it has got a motor, and it has got a read write head, and it has a magnetic drive inside it, right, which stores the data. So now the disadvantage with magnetic drive is, I mean, if you use the magnetic drive, it's again, there is potential loss of data when you don't preserve it properly, right? Because that's a magnetic drive, right? I mean, if you put it in a very high magnetic range, you may tend to lose the data. Secondly, since it's a moving part, anything which is like moving part is tend to get degraded in its performance over a period of time, right? Like how you have your mechanical cars, right? Cars, your two-wheelers, right? So where you need to maintain it very well, right? I mean, you have to service it properly, you have to change the oil and things like that, right? So similarly here also, since it contains a lot of moving parts, there is a possibility that the wear and tear of the moving parts could degrade the performance of the disk over a period of time. Okay, so now then came I mean, right from day one, always the memory RAM used to be a chip, which is a flash, okay, which is very, very fast, right, which is called ROM, right? RAM and ROM, correct? Random access memory, right? So that used to be very fast, right? So where the throughput of a memory is much faster than the throughput of the hard disk. So that's why if you see, memory is used as a temporary place, where data comes and sits on top of memory from hard disk, and then CPU processes it, and then again it sends it back to the memory, right? So that's where, if you have less memory, then your system actually degrades in its performance, right? You should have the right memory for your programs to run properly. So now then what they thought was that, okay, why don't we use the same technology that we use in memory, but to store data completely persistently, right? Usually what happens is what you store in memory is not persistent. It is ephemeral in nature, right? Because once your computer shuts down, whatever data that you store in memory will go away. Next time when the computer starts up, the data is not there anymore, correct? But that's not the case with hard disk. Hard disk is permanently stored until you delete it. Now they thought, okay, why don't we just merge these two and create one drive called SSD, where we can use the chips from memory, RAM, and then where we can also make it persistent, permanently persistent, so that it can perform much faster. That is when SSD started coming into industry. Okay, now SSD is 10 times faster than your hard disk. Okay, you can try it out actually, right? You can do benchmarking and you can try. Okay, SSD is 10 times faster than a hard disk drive, right? And magnetic drives, and then it can basically give you much better performance to your server. Okay, so now basically if you see optimized for transactional workloads involving frequent read or write operations with small IO size, where the dominant performance attributes is IOPS. IOPS stands for input output operations per second. Input output per second, that is called IOPS. So this is a very important term. You all need to understand this. Okay, with respect to storage, it is called IOPS, in input output per second. Okay, so usually the input output per second is, if your application is reading and writing from your underlying storage, it must be making a lot of calls to your storage, right? Like it must be randomly reading a lot of data and then writing a lot of data, correct? So that's measured as IOPS, input output per second. So that's where solid state drives became very popular, and solid state drive became the standard in all enterprise enterprise data centers, cloud, where cloud providers like Amazon built a huge array of SSD drives. Okay, again, the way SSD also, it's also a SAN only at the end of the day, but instead of using magnetic hard disks, they use SSD drives. Okay, which uses the flash chips to basically store data, and which is persistent data. Okay, so then you have hard disk. Amazon also has got hard disk. Okay, if you want to optimize on cost, because SSD is expensive than hard disk because of the technology that it brings, correct? And also it's expensive to buy SSD, right? In fact, I bought one SSD recently. I bought a I think 250 GB SSD recently. It costed me about some 3,500 or something. Okay, but the same for 3,500 rupees, you can actually buy a 1 TB Seagate hard disk drive, the non-SSD one. Okay, so that's why it's quite expensive. And so then you also have hard disk drives, which provides the standard magnetic experience to your customers. You can also use that. Okay, so now these are the two things that you need to understand. So now there is a code for, there is a type that is associated with both SSD and magnetic. Okay, so now within SSD itself, there are different types of SSDs that are there in Amazon, in EBS. Okay, for various performance requirements, right? It's like this, right? So where when you want to buy a light to light your room, correct? So now you have different wattage in your bulbs, right? So the lighting bulbs that you get. Okay, if you just need a small one, which is for just for the night purposes, night lamp, right? Then you buy something which is maybe a 0 watt or a 5 watt or a 2 watt, 3 watt, correct? Which is very small. I mean, not small, it's very low in its capacity, correct? But whereas, if you want to light an entire room, right? Then you need probably a tube light, or you need an LED lamp, which is about say 50 watts or 25 watts, correct? But imagine if you want to light a stadium, okay, floodlight, okay, IPL matches going on night, 11 o'clock, full swing. Okay, final over is being battered, right? So in that case, what you need to light an entire stadium. So then what will be the wattage requirements for it, right? It will be a huge, and not just one, you need several of those, correct? So now again, even in EBS, it is very similar to that, right? So where if you have an application which is not so heavy in its IO disk read write operations, right? It is not doing so much of read and writes. You just need a normal one. Okay, then you can go for GP2, which is called general purpose. Okay, it's called GP2, which is a general purpose, which provides a balance of price and performance. So I have a room. I just need probably a 15-watt LED bulb, okay, just to light my room. That's good enough. It's a small room, maybe 100 square feet or a 200 square feet room. Okay, so I don't need to light my room with 100-watt, right? Because it's a overkill for my room, right? One is obviously the price is too high, and secondly, I don't need that. So I don't need so much of power, right? I need 25 watt is good enough for me. So in this case, you just go for a general purpose SSD, which provides a balance of price and performance. It delivers the right performance that is required for you. And actually, if you see, general purpose is good enough for most of the applications, most of the workloads. Then you also get like, for example, I moved to a slightly bigger room. From my 100 square feet room, I go to a new flat. Now, in this case, my study room becomes 400 square feet. It's a huge room. Okay, but in my 400 square feet room, I mean, I'm not just sitting there alone. I've got a bunch of my friends. We're all doing a group study, right? I need a slightly better bulb, which can light my room. So then I'll go for 100-watt. Maybe not one. I'll go for a few of them, 2, 3 of them, right? Or 75-watt. So such case, provisioned IOPS SSD is equivalent to that, right? So where it provides high performance for mission critical, low latency or high throughput workloads, right? So where you have got two types of provisioned IOPS SSD. So where you've got IO1 and IO2. IO2, in fact, was just launched recently, about a month back, but IO1 is there for quite a long time now. Okay, so now it basically provides you here. What you can do is you can specify the IO that you require into input output operations that you require. Like in a general purpose SSD, you can't specify that. Okay, it by default it provides you a standard benchmarked IOPS. It's called input output per second. Okay, which is basically the metric which is used to measure the performance of your drive. Okay, so where if you are reading and writing from your drive, it is basically the IOPS. It has to go read from the drive, right? So it's basically the IOPS which tells what is the IOPS that your drive is actually delivering. So if your IOPS is low, like if your drive is only capable of performing say 100 input output operations per second, right? So then what happens is you're not able to meet the performance requirements of your application, because your application needs 500 input output operations per second, but your drive is only able to deliver 100 input output operations per second, right? So you can't go beyond a certain point. One more example I'll give for you guys to easily relate to. You've got engines, right? You've got car engines or bike engines, right? Okay, so let's take bike engines itself, right? You've got a 100cc vehicle, you've got a 125cc vehicle, you've got a 300cc, a 350cc, or Royal Enfield, right? Royal Enfield provides you up to 350cc or even 500cc, I believe. Okay, so now in a 500cc vehicle, you can push the speed up to or probably 120, 140 kilometers per hour. Okay, whereas in a 100cc vehicle, right, where you have a 100 or 125cc vehicle, you cannot push the 125cc vehicle engine beyond a certain point, right? In such cases, that is the limitations of the engine, right? Because it cannot go beyond a certain capacity of burning fuel and giving you power and giving you the torque that is required for you to push your vehicle forward, correct? In such cases, you need a higher capacity engine so that, like you take Formula One racing and all, right? They have, I mean, their engines are so powerful that, that they can actually drive at like 250 kilometers per hour. 250 kph and maybe 300 kph, right? And you take flight engine is even more powerful, right? So where it can even go up to, on the ground, it can go up to like 300, 350 kilometers per hour. Okay. Whereas in the air, it can go up to like say 1000 kilometers per hour speed. Okay. So now that's basically the difference between GP2, IO1 and IO2. Whereas in IO1 and IO2, you will be able to specify IOPS that you require. That if you need more IOPS, you can specify that IOPS. You can say that I need 1000. I need a huge IOPS. I need 1000 IOPS per second. You can say that I need 1000 IOPS. Then you say, okay, now my database has grown. I need say 10,000 IOPS. You can say that 10,000 IOPS. So IOPS is nothing but your kilometers per hour. Okay, IOPS is similar to that. So based on the kilometers per hour requirements that you require, so then you change the engine type. Engine type is GP2, IO1, IO2. Okay, and then you've got some other matrices such as what is the throughput that it can deliver, right? The throughput is 128 megabytes per second and 250 megabytes per second. Throughput is again how much of data it can basically read from the disk and then send it back. It can be up to like 250 megabytes per second. Okay, and then you can just read about this. I don't want to go too deep into these because I want you to understand that there are 3 types of hard disks available in EBS. One is called SSD, and then in SSD there are 2 types. One is general purpose SSD, the other one is provisioned IOPS SSD, and then you have got the magnetic hard disk drive, which can provide you throughput optimized and cold HDD. So this HDD type in EBS is magnetic drives. It is not SSD, the traditional magnetic drives. So where throughput optimized HDD is a low cost hard disk drive designed for frequently accessed throughput intensive workloads. I think somebody has to go on mute, please. Yeah, okay. And then you have got a cold HDD where, I mean, it is not very frequently used, right? So I just need to store the data there. I'll forget about it. Maybe once in a year, I read the data. So even if it reads it slowly, I don't care, because for me, price is very important for me, right? I mean, price is the most important factor for me. So I'll just store everything in a cold HDD. Cold HDD is nothing but provides very low performance, but I'm okay with the performance. I'm okay with that. Okay. So that's where, if you see, you've got various different options. Okay, SSD and HDD. SSD has got general purpose and provisioned IOPS. And in provisioned IOPS, you've got IO1 and IO2, two tiers. And in HDD, you've got ST1 and SC1. ST1 is your traditional, right? Now, most of us, we have laptops and desktops, right? Where we have hard disk. So all those are equal to this throughput optimized HDD. Okay. So now there are use cases for each one of those, so which can be used appropriately. But still, I mean, before you make the right choice, you also have to understand what is your applications requirements. I mean, if your database is quite intensive from the file system perspective, where it uses the IO quite frequently, so then you need a better performing disk so that your database can run efficiently. Otherwise, your database will not be able to run efficiently, because at the end of the day, if you don't give the right hardware to your databases or applications, your performance will not be at par. Okay, that is where you have to make the choice. Okay, so these are certain advanced things. Don't go into too deep at this point in time. I'll leave it to you. You can read about this later on. But first, try and understand what EBS means and how you can create an EBS and how you can choose the right EBS for what you require. Okay. Okay. So now let's do one thing. Let's get back to our business. Okay. So now for the sake of this lab, what I'm going to do is I'm going to actually provision a new EBS instance. So now in this case, I have a public EC2 instance where I have, if you go to the storage tab here, you will know what are the block devices that are attached to my EC2 instance. Right now, there's only one block device, which is the volume size is 8 GB. It is attached to it. What time I attached? Is it encrypted or not? It's not encrypted. So now if you want to see, you can also go down and you see this elastic block store, and then click on this volumes. You will see the volumes that are provisioned, EBS volumes that are provisioned. You will see the complete list of it. Okay. And you see the size of that. It is 8 GB, 8 GB. What is the volume type? GP2. What is GP2? GP2 is general purpose SSD. Okay. General purpose SSD is GP2. Always remember that. Okay. And the IOPS that it gives us, it gives 100 IOPS. What is 100 IOPS? What is IOPS? Input output per second. So this can deliver up to a maximum of 100 input output per second, which means read or write per second. It can allow those many operations. Okay, what is input output? Operations. Those many operations it can allow in a second. Okay. Yeah. Yeah, and then you can see other details about it, right? And if you see the state which says in use, which means this particular volume is in use on some EC2 instance. What is that EC2 instance where it is in use? It is attached to this EC2 instance. Yeah, it's actually attached to this particular EC2 instance. And this volume is attached to this EC2 instance. Okay, so now what we will do is, let's go, I'll show you how to provision and you know how to provision an EC2 instance. But now what we'll do is we'll just provision a new volume. Okay. Okay, I'm just going to use here, when you say create volume, you will get a drop down like this under create volume. Here you can select what type of instance that you want to select, whether you want an SSD or you want a hard disk drive. Okay, so you have GP2, IO1, IO2, SC1, which is for cold, which is the least performance. Then you have ST1, which provides a slightly higher, better throughput optimized HDD. And then you have a magnetic, which is the standard one. Okay, that's also a hard disk drive only, but which is a standard one. Okay, that's actually a very low price. In fact, if you want to know the price of this, right, just search for EBS price. You'll see the difference. Yeah, as part of free tier, you get 30 GB, right? I've been telling this for a while now. You get 30 GB of storage, 2 million IOPS, and 1 GB of snapshot storage, right? So that's, ignore that. But let's come to Mumbai. I'll see what is the rate in Mumbai. If you go to Mumbai, GP2 volume is 0.114 per GB per month. Okay, which is, I'll do a calculation. .114. Yeah, this is like 0.114, correct? Per GB per GB per month. Okay, so now assume I've got 100 GB. Okay, equal to 100 into 0.114 is, I'll be incurring $11.4 per month. So $11.4 is 75. Yeah, 855 rupees per month for 100 GB. This is for GP2. Okay, Whereas if you actually go for yeah, throughput optimized HDD, right? This one, which is 0.051. Okay, which is 0.051. Okay, which will be how much? 0.051 into 100. Yeah, see, it's like almost half, $5 per month, which is about some 380 rupees. This is ST1. If you further go for the lowest one, which is SC1, which is 0.029. Okay, I'll just change this to 0.029. Yeah, see, it's like 200 rupees per month for 100 GB. Okay, so that's how you calculate this, and you know the difference between like price, right? And if you go for IO1 or IO2, that is even more higher, right? I mean, if you see, it is 0.031, right? So it's just 0.131, sorry, 0.131. So if you see here, you get rupees 855. Here you get rupees like 982, plus you have to pay for the how much our provisioned IOPS. Say for example, for 100 GB, like say I'm provisioning another additional say 1000 IOPS. Okay, so in that case, what will happen is this plus 1000 into 0.068, 0.068 cents. Yeah, see the difference. It goes to here it is like $11. So here it is like $81. Okay, instead of 1000, let's say I'm like going for 500 IOPS, it'll be like $47. Okay, but this delivers better performance. If you want applications which are, you have databases like Oracle databases are running, and your Oracle databases needs more IOPS to sustain your queries, right? I mean, Ravi sir is there. Ravi sir is a database expert, right? I mean, he knows much better, right, in terms of how databases will fail pathetically if there are underlying storage level issues. If your underlying storage is not able to deliver the performance to the database engine, then your queries will time out. Your queries will take longer. Okay, a query which is supposed to probably get executed in say 10 milliseconds would take about a second, 1 second. Right? In such cases, your application will have an impact. Okay, your end users who are actually trying to access your application, trying to perform some operations with it, functionality will get impacted badly. Okay, in such cases, you have to go for a better one, which is like IO1 or IO2. Plus, but it comes with a price, right? It comes with a price as per the capacity that you provision plus the additional IOPS that you throw at it. Okay. All right. So let's go back to our page. Then I'm at the create volume. I'm just going to create a GP2 here. Okay. The GP2 for GP2, the IOPS that you get is standard IOPS. Okay. You can't choose the IOPS. Okay. And based on the, so what Amazon gives is AWS gives us per GB of GP2 volume that you provision, they give a baseline of 3 IOPS per GB. So in this case, for 100 GB of my GP2, I get 300 IOPS, and it can burst up to 3000 IOPS. Okay, there is a burstable, it's burstable. So where suddenly, my application starts seeing a lot of requests, and your application is writing a lot of data and reading a lot of data from the disk, which is not sufficient. Your 300 IOPS is not sufficient. I mean, it is going above 300. So then in that case, what it uses is it can go up to 3000. But there is a limit to it where it gives you credits. Okay, and if you don't use that credit, you can use that credit whenever there is a peak scenario that is coming. Whenever suddenly there is a peak scenario, you can use that credits, but those credits will get exhausted soon. Okay, so then once the credits gets exhausted, what will happen is then it will fall back to the baseline performance, which is 300. So then your application will start seeing issues. That is also a problem. Okay. So now, but imagine, I mean, don't go too deep into that. I mean, you may not understand that completely, but for now, understand that GP2 is a standard general purpose SSD volume. Okay. And then you get a baseline performance, and you can, Amazon gives you 3 IOPS per GB of volume that you provision, right? So for example, I'm only provisioning, let's say 10. Okay. So then you get 100. Like say I'm provisioning, like say 200 GB, right? When I provision 200 GB, I get 600 IOPS with that. Comes with that. Okay. So now for now, I'll just provision maybe a 30 GB only. Okay, I'll provision 30 GB. So then what you do is in availability zone, you can specify which availability zone you want that to be provisioned. Okay. So again, your EC2 instance availability zone here is, let me go back. Let me see what is the EC2 instance availability zone, because you have to provision the volume in the same availability zone. Okay. You can't take one volume which is provisioned in one availability zone and attach it to the EC2 instance which is in other availability zone, because the latency will be higher. Because if it is in the same availability zone, it is actually in the same data center, correct? That way your SAN is attached to your EC2 instance in the same availability zone. Okay, so here which availability zone that I've provisioned this in? Yeah, AP South 1A is where I've provisioned this in. I'll provision a new one, create a volume, general purpose. I'll provision, say, yeah, I'll provision 30 GB. Then AP South 1A. Snapshot, I'll come to the snapshot later on. Snapshot is again a way to back up your block volumes. If you want to take a, how many of you have used ghost images? Do you know what a ghost image is? Ghost image is nothing but it's a software which is there. You can install it in your laptop or desktop. Now, if for some reason your laptop crashes, you will lose the hard disk because your hard disk will go bad, right? So when you change your hard disk, you will lose all your data with it. But Ghost is a software, which gives you, it's a tool utility which allows you to take a snapshot of your entire hard disk at a point in time. Okay, so that if your hard disk crashes, if your C drive crashes, you can easily bring the ghost image from a point in time snapshot and then put it back. And then it'll, like, say, for example, I've taken a ghost image sometime 10 days back. And today my hard disk crashes. So what I'll be able to do is 10 days back, I have a ghost image. I'll bring that back up and then put it back. And it'll be restored back to the state which my C drive was in 10 days back. So that's the ghost image. Okay. So now snapshot is again very similar to that. We'll come back to that later. I'm just going to add a tag here saying name. I'm just saying data volume. I'll just say create. So volume gets created. So if you see, volume got created immediately, but it's available, right? It's not in use, it's available. Okay. So now what I can do is I can actually, if you see here, it is not attached to anything, right? Yeah, attachment information is not there. So it's blank. It's not attached to anything. So what I can do is I want to attach it to my EC2 instance, right? Right now my EC2 instance has got only one drive attached to it. My public EC2 instance has got, sorry, let's go to storage. It has got only one block storage attached to it, right? Which is the other one. So now for me to attach, I have to click on actions. I get so many options here. I can say attach volume. Okay, I get this here. Select the instance which is running. Okay, it will only list down all the instances that are running in AP South 1A. So there's only one instance which is running in AP South 1A. The other instance is running in 1B. Okay, that's our design, right? That's what we did in VPC. So select that, and then you can so in Linux the way it works is you attach the volume, right, and then you basically mount it on a specific path. Correct. Okay. So in this case, it's mounted on /dev/sdf. You can just leave it default, right, and then say attach. So it will get attached to it. So if you see, yeah, it is in use. It is attached. It is attached to the EC2 instance, and the volume status is okay. All right. So now go back to EC2 instances, and then refresh the page. Select on your public EC2 instance. Go to your storage. Now you see you have two volumes attached to it. Volume 1 and volume 2. The volume 1 originally what we provisioned is 8 GB, right, which is the root volume which we provisioned. Now I have provisioned an additional 30 GB of hard disk of type GP2, which is SSD, general purpose SSD, and I've attached to it. Attachment time is November 2nd, which is today. Okay, so now it is attached. Now, how do we access that volume, right? To access that volume, you have to go to the operating system. Let's go to the operating system. Let's first connect to that EC2 instance using our public IP address. I'm going to connect to my EC2 instance using PuTTY. I'm going to go to PuTTY. I'm going to say EC2-user @ public IP address. I'm going to say auth, give the private key file. I'll say open. Yeah, it's connected. So in Linux, in Windows, it's easy, right? So where you go, you get a graphical user interface. You go to disk manager, disk management, and disk management. The moment you attach an EBS volume to it, you will see it here, and then you can just say right click and format and do whatever you want. But in Linux, it is different, right? Because you don't get a graphical user interface. Now for Linux, you've got a way to attach it, right? I'll just show you. I'll give you the link also. I'll also tell you how to do that. EBS volume attach Linux. Yeah, not this. Yeah. So this article will actually ask you to attach it to the EBS volume, and then it will give you the steps to perform so that you can attach it. Okay. The first step that we need to do is now if you see lsblk, okay, ls is list. Okay, we know about ls command, right? blk is nothing but block. So lsblk is a program which is a command which tells you what are the block devices that are attached to my Linux instance. So here, if you see, there are two instances. There are two blocks that are attached to mine. One is xvda, which is my root volume, which is of 8 GB, and then xvdf, which is 30 GB. Okay, which is the new one that is attached to my Linux instance. Okay, so now what you need to do is you need to take this disk, the new disk that is created, 30 GB, and then you have to mount it in your Linux so that it is usable, so that you can read and write files from it. So now how do I mount it? For that, what you need to do, you have to go to a folder called /dev. Okay, so if you go to /cd/dev and then say ls-l, you will see so many folders here. Basically, these are all the devices that are there. Okay, these are the devices. Dev is a devices folder in Linux, right? I mean, in the first week, I'd explained you what the folder structure within Linux looks like, right? So these are nothing but the devices that are there in Linux. Okay. So what you can do is you can actually, you know what is your folder name. Okay. First what you have to do is you have to format your drive that you have attached to your Linux instance, right? So in order to format, there's something called MKFS. Okay, MKFS, and in Linux you use XFS. The file system is XFS, like your NTFS or FAT in Windows. In Linux, it is called XFS. So you have to first go create a file system out of it and format that file system. Okay, so what you have to do is, I mean, the previous steps are actually showing, determine whether there is a file system on the volume. New volumes are raw block devices, and you must create a file system on them before you can mount to use them. Volumes that were created from snapshots, ignore that. Okay, use the file -s command to get information about a device, such as its file system type, which output shows simply data, as in the following example. There is no file system on the device. Okay, so now what you have to do is you have to take this name that you get from it. Okay, so now what is the name that you got from the previous command from lsblk is xvdf, correct? That is the name that you got. So then what you do is execute this command sudo file -s/xvdf. Sudo file, you have to do all of this as sudo privileges. Sudo is nothing but supervisor. Okay, administrator privileges. Sudo file -s/dev/xvdf. So when you say it is just data, nothing is, no file system exists on this. It's just a raw block device. Okay, so then what you do is, then you do mkfs xfs. Okay, so when you say sudo mkfs, it is called make file system, which is like formatting the file system, right? XFS, what is the type? Type is XFS, and what you want to format? You want to format /dev/xvdf. And imagine we gave this xvdf when we mounted when we created the EBS volume and when we attached it to the EC2 instance. Where did we do that? We did it here. If you see here, yeah. Okay, of course it is /dev/sdf, but eventually when it gets presented to Linux, it will go as a xvdf, but the df will be common. Okay, so now sudo mkfs-t xfs/dev/xvdf. Just hit it. What it does is it basically creates a file system. It formats the file system also. Now you repeat the same sudo file -s/dev/xvdf. It will show that this is file system of type XFS, and the block size is 4096, whatever it is, right? So, okay, go back. Okay, so now what you can do is you can create a new folder somewhere in the root. Okay, I'm going to my root cd/ls-l. In my root folder, I'll create a new folder called sudo mkdir data. Okay, I've created a new folder. I'll again do an ls-l. Yeah, you find a folder called data. So now you want to use this folder to mount the newly provisioned 100 GB onto this, or 30 GB onto this. Okay, so you need to mount it. Like it's like formatting and mounting, right? You need to just mount it. So then what you need to do is you have to give this command sudo mount /dev/xvdf/data. I'll clear the screen. I'll say sudo mount /dev/xvdf. This is the source. This is the source volume. I'll mount it where? I'll mount it in /data. Okay, so when I mount it, it is actually mounted in my /data. So now if I go to cd/data, and when I say ls-l, I'll be able to start using it. Okay, until that point, I won't be able to use it. My /data will not give me anything. Right? Now, if you see, my slash data is ready to use. And if I say df minus eh, yeah, if you see my slash dev xvdf. So df minus th is basically a utility which will tell you, which will list down all the disks that are attached to your server, Linux server. Okay. So now if you see my slash dev xvdf, which is the newly provisioned 30 GB. Okay. And I've mounted it on slash data. Whereas xvda1 is basically the one which got provisioned at the time of provisioning my EC2 instance, right? Which is the standard 8 GB root volume. Okay, that is mounted on root. Whereas I created a new folder called slash data. This can be anything. I don't want you to think that, it has to be always data. It can be anything. It can be your name also. Okay, it can be anything. You can just create a new folder under root or anywhere for that matter. And then you can mount it using the command sudo mount slash dev, the device name, and slash folder name. So it will be just mounted on that particular folder. So now you can you can start using this and you can keep using this. Okay, so that's how you create a new EC2 instance, and then you mount that EC2 instance on your, so mount the EBS volume on the EC2 instance. Okay, so now you can actually write some data to it, right? I'm on the slash data, correct? I'll say sudo vi file 1.txt. Okay, I'm saying this is my file 1. This has some contents in it. That's it. Good with it. Okay, I'll just save this file. So now that file is actually stored in the second volume that I created, the 30 GB volume that I created. File 1.txt is there. Okay, perfect. So now I'm going to show you something else. I'm going to show you how to take snapshot of this and how to make use of this in other computers also. Okay, so now we created a new volume. Okay, so now one more thing is, in Linux, what will happen is when you create a new EC2, when you create a new EBS volume and attach to the EC2 instance, anything which is other than your root volume, when you reboot your EC2 instance or the Linux instance, if that whatever mount point that you created, that will go away, right? So now for that, you need to edit a file called /etc fstab file, so that every time it persists, right, you can basically persist it every time the EC2 instance reboots. Okay, you can just follow the steps. It will allow you to persist it so that next time when the EC2 instance reboots, the same mount will be available. You don't have to recreate the mount point every time, so that your applications will be able to continue to write to your that EBS volume, right? So anyways, I'm not going to show you that. It's pretty self-explanatory. You can just do it yourself, this portion. I'll give you this article. You can read this article and you can follow the steps. But now what I'm going to do is, I'm actually going to, so now this is my public EC2 instance, right? Which has got now 2 volumes attached to it, right? Yeah, 2 volumes. Let me go to my other EC2 instance, which is my private EC2 instance, right? So this is my private EC2 instance. So my private EC2 instance has got only one standard 8 GB volume attached to it, right? Now, what I want to do is, I want to basically take that 30 GB, which is attached to this. I want to take a copy of that and attach the same copy to this also. Okay, so that, because, what I have done is I've written a lot of files to it. Okay, now I don't want to just copy it file by file. Okay, rather what I want to do is I want to simply take that entire block as it is, take a copy of that entire block device, and then attach it to my private EC2 instance, so that my programs in private EC2 instance will also be able to access those files. But it's just a copy, it is not the same. I'm taking a copy of it and attaching it to that. Okay. Conceptually, how it will look like is, okay, it's not C drive, it's basically root, and this is /data. This is root, this is /data. Root is 8 GB, /data is 30 GB. Okay. Now /data is also attached to my EC2 instance, correct? Now what I want to do is, I want to take a copy of this. Okay, and then I want to attach it to this one. Yeah, I can do that. Now this also will have the same / by default it has, right? When you provision an EC2 instance, this also has got that. Where this also will have this. So now that is when snapshots will be helpful. So now I'll go to my volume, the new data volume that I have, right? So this is my new data volume. I'm just saying create a snapshot. I'll say snapshot of data volume. I'll give a tag to it, name snapshot 1, data snapshot 1. Just go create a snapshot. So what will happen is, it will actually, if you go to the snapshots folder for snapshots option, you'll see that a snapshot of that is being made. So it'll just take a while, about a few minutes. 28% is done. Let's just wait for that to complete. So now a snapshot is basically available, and let's just wait for this to complete. So then what we can do is, we can actually take this and attach it to the other EC2 instance. Okay, but before that, let me actually create a new EC2 instance in that same availability zone. Oh, okay, wait, we'll do that as the next step. For now, let's just complete the snapshots. Okay, so snapshot is completed. Okay, snapshot is completed. So now what I can do is, if you see, snapshot is created for this 30 GB volume. And what time snapshot was done? Snapshot was done at 11 AM. Okay, so now this will remain for as long as you want to keep it. It is like a copy of your volume, entire volume, at that point in time, right? For example, if you remember, within this, we created a file called file1.txt. This file1.txt will be there in that snapshot. Okay, now what I'm going to do is, I'm going to add one more file called file2.txt. Okay. This is file2. Okay, so now I created a file2 where I created a file2 in this. So now this has got file1 and file2. Okay, this has got file1 and file2. Okay, so this has got file1 and file2 in it, right? My EC2 one in the public is present, is having file1 and file2. Okay, but now what I've done is, I've taken a snapshot of my EBS volume before I created file2, right? Because I took the snapshot at 11.1. Now at 11.4 I created file2, right? So obviously the snapshot will not have file2 in it. It will only have file1, correct? Okay, because it's a point in time snapshot. At that point in time, I took a snapshot of it. It's like this, right? Snapshot is nothing but taking a photo. Okay, in a room, there are 5 people sitting in a room. Okay, at 11 o'clock. Okay, I take a snapshot, I take a photo of that room. Okay, with those 5 people sitting around the table. Okay, that photo will have that 5 people, correct? So after about 5 minutes, a 6th person comes and joins that table, that room. I take one more photo of that room at 11.5. So that photo at 11.5 will have 5 people sitting in it, right? Whereas if I go back to the photo at 11.1, it will only have 4 people in it, because that's the point in time, right? The point in time snapshot. Snapshot is also taking a, it's like taking a photo or taking a complete copy of that volume at that point in time. So any changes that happened after that will not be present in that snapshot, because those are real-time changes. Okay, so now I can just go and I can attach that to my, I can create a new volume in 1B, but you know what I can do is I can actually use my new snapshot that I created. Select a snapshot, say data. Okay, in fact, what I can do is I can just go select this and create a volume out of it. Okay, go to snapshot, click on create a volume out of it. The same, right? I mean, but instead of creating a fresh volume, I'm creating a volume out of a snapshot. Okay, where I'm actually taking that photo. Okay, and then I'm taking the negative of that photo and then I'm getting it developed, right? It's like that. Okay, I'm just taking one more copy of that photo and then I'm attaching it to somebody. I'm just giving it to somebody. Okay, it's like a copy of it. So, but I want to basically create that snapshot in 1B, because my EBS volume, the other EC2 instance is in 1B, right? Which is 1B. It's in second subnet, which is in 1B, availability zone 2. Okay, that is where I want this new volume to be provisioned and attached. So I'll just say add tag name data volume EC2 instance 2. I'll just say create volume. I've created a volume. So if I just go to my volume, you will see that second volume is getting provisioned of another 30 GB. Okay, but that is coming from a snapshot of this, snapshot of my primary data volume. Okay. Okay, it is in creating mode. Let's just wait for it to create. So let it create. In the meantime, I'm going to put it into the other EC2 instance from here. Okay. Yeah. So now let me just do. I'll go to my EC2 instance. I'll go to my EC2 instance. I'll go to my private EC2 instance. My private EC2 instance, I can't connect it through internet, correct? I need this 10.0.2.8. That is my private IP address. Again, these are basics. You guys would have done it and understood this by now. SSH -I RPL lab, right? RPL lab Mumbai lab.pem EC2 -user @ private IP address. Give the private IP address, which is 10.0.2.8. Okay, connect to it. Yeah, you're connected to the private EC2 instance through my public EC2 instance. Okay, so now here I'm just doing an LSBLK. What you have is you don't have the 30 GB attached to it as yet, right? You only have the 8 GB which is attached to it. Now let's attach the 30 GB if it is provisioned. Let me go back to volumes. Let's see, has it created a new 30 GB? Yeah, it is created and it is available. You can attach it to your EC2 instance. I'll just go attach each volume. Okay, here if you see, since my volume is provisioned in, okay, since my volume is provisioned in my AZ2, if you see, my volume is actually provisioned in availability zone 2. AP South 1B. Okay. So because that's where I provisioned it from the snapshot, right? Snapshot is again just a copy. Using that copy, I instantiated one new volume using that copy. You can create as many as you want, right? So that is provisioned in 1B, because again, remember, volumes are specific to availability zones like EC2 instances. Okay, you can attach a EBS volume, which you created in a specific availability zone, only to an EC2 instance, which is there in that availability zone. You can't do it crisscross. Okay, so now it is there. So now I can just go attach a volume. So when I attach the volume, when I click on instance, it will show me all the EC2 instances that are running in that particular availability zone in South 1B, not in 1A. Now, if you see, I'm not seeing the public EC2 instance here, right? So select that. Again, just leave it default and then say attach. Just wait for it to be attached. Yeah, so it is attached now. You will see that the state has changed from available to in use. So now go back to PuTTY. You're already connected to your private EC2 instance. Now again run lsblk. You will see the difference here, right? So if you see, it only had xvd a1. Only these two lines were there. So now there is a third line which got added here, which is 30 GB disk got added here. Okay. Again, follow the same steps which is provided in this article. Okay. Sudo file /dev/xpdf. Okay. Here, if you see, it is not showing it as nothing, right? It's already available because there's already a file system which is there in it, and there are some files that are already available in it. What files it has? It has file1.txt in it, and it is already formatted and ready to use. So you don't have to format it again. That's why if you see, if you format it once again, you will lose all the data. So don't format it. You see this warning. Do not use this command if you're mounting a volume that already has data in it. For example, a volume that was created from a snapshot. Otherwise, you will format the volume and delete the existing data, right? So don't do these steps. Don't do sudo mkfs. You will end up deleting the data in it. Okay, your purpose of doing this is you want the data to be present in the other EC2 instance as well, correct? That's why you're doing a copy of the data to be present in the other EC2 instance as well. So you can skip all of this data and then you can just straight away come and mount it. But in order to mount, you have to first do cd/sudo mkdir data. Okay, so then sudo mount /dev/xvdf to /data. Okay, yeah, here you go. You have mounted it to /data here. So now you can go to cd/data and then you can do ls-l. What will you find if you do ls-l? How many files will be there? Can somebody answer?
One.
Only one, sir.
One file. Excellent. Yeah, here you go. You have only one file here. Okay, and then cat file1.txt. Yeah, this is my file one. This has some contents in it. Okay, so now, yeah, so now the other one has got two files in it, right? Which is basically the real, the real-time one. So if I say a new session, and then I will just go to public EC2 instance, load it. What is the IP address? IP address has changed. We'll just bring the IP address back. New IP address, public EC2 instance, yeah, 1332.89. Okay, yeah, so I'll just connect open. Yeah, so this is my public EC2 instance, right? This one. So here if I go to cd/data and then say ls-l, this will have two files in it. Whereas this has only one file in it. File one, here you have two files in it. So if you again want to do this, you can do this. Okay, so now the use case here is, now you will have a lot of data that you're writing, right? So now snapshots is a good mechanism to back up your data, right? You can configure automated snapshots for your EC2 instances, for your data volumes especially, right? And you can basically have these snapshots, store these snapshots, like say for a 15 days period. After 15 days, you can automatically delete the older snapshots. Okay, so that way you are basically taking a backup of your underlying entire EBS volume, and then you're using that backup. In case if something goes bad, right, in the last 15 days, You can always go back and then go back 1 week and past, and then get that volume, get that snapshot. You can create a volume out of it, restore that volume. You can take the data from the previous days of snapshots. That way it is very useful. It's a very cool feature that AWS offers, right? So where you can basically create a new instance using a snapshot, right? And you can basically bring back the entire data into the new EC2 instance automated way within a few minutes. Okay, you don't have to worry about it. Yeah, and everything is done using commands, and you can use the console to go create a volume. And when you create a volume, the volume can be either created from fresh, or you can select a snapshot. From that snapshot, you can create a volume. Okay, or you can also go to snapshots from a specified snapshot. You can create a volume out of that snapshot, where you're using this snapshot to create a new volume, and you can attach it to an EC2 instance. Okay, so now this is what it is. So now let's go to today's assignment. Okay, so now most important thing, what I want to do in order to keep your cost low. Okay, so now we have created a lot of volumes and snapshots, right? You'll unnecessarily start incurring cost on it, right? So let us do a cleanup. Okay, let us do a cleanup of all of those, right? So for that, what I'll do is I'm just going first deleting my snapshot. I don't want the snapshot any longer. I'll just go click on delete. Yes, go ahead and delete it. Yeah, gone. So I am not going to incur cost on additional snapshots. Then I'll go to volume. Okay, so before I delete my volume, let me first unmount it from my EC2 instance, right? So for that, what I'll do is sudo umount /data. Okay, I'm actually in the data volume, so that's why it's not allowing me to unmount it. I'll go to my root volume. Just look at it carefully. I'm going to my root volume. I'm actually trying to unmount it from the data volume, so that's why it is saying it is busy, because it's being used, correct? I'll go to my data volume, and then I'll type sudo unmount u/data. So then say df -th. You will see that it is not mounted. Data volume is not mounted anymore, right? Similarly, do the same thing on the other instance also. I'll move out of data volume, sudo umount /data. So you have unmounted it. So now you don't need that volumes anymore. So what you can do is you can first select the one that you created here, and then you say first detach volume, right? You have to first detach it from the EC2 instance. Say detach volume. Yes, detach. Just wait for it to be detached, so that it'll from in use it will become available. The status will become available. Yeah, see it's available, right? So now click on actions and then delete volume. Just say delete. Yeah, it'll go into deleting stage, and eventually it'll get deleted. So now you also do the same thing here for the other volume. Just say detach volume, detached. So the moment you say detach, so now let's go back to our LSBLK. Okay. Okay, I will say LSBLK. Yeah, you will see that the 30 GB is no longer attached to your instance, EC2 instance. You only have the root volume, which is the 8 GB, which is there. 30 GB is gone from this, right? Because I've detached it. Okay, so now it is available. I'll just say actions, delete volume, delete. Yeah, so now it will say it is deleting, and in about a minute or so, this will go away. So now you have deleted. Now you have cleaned up the entire thing. Now what you're left with, only these two volumes, which are part of your private EC2 instance and public EC2 instance, which is the root volume of 8 GB. You leave this. I mean, don't delete this. Leave this. If you delete it, your EC2 instance will crash. Okay, if you detach it, your EC2 instance will crash. You should not detach it. So just leave it like this. Okay, and you have cleaned up snapshots, you have cleaned up volumes. You're good. Okay, so now assignment for today. Let's go to assignment for today. Today is 2nd November. Okay, so the first link that you have to read through is, yeah, this one. EBS. Okay, so then look at the volume types. Yeah, and then I also wanted you to read about SAN, correct? Okay, so then when it comes to assignment, 2nd November, just going to knock off all of this. Okay, first is open EC2 console, navigate to EBS volumes. Yeah, navigate to EBS volumes. Tab menu on the left pane. Okay, then click on volumes and then say create volume. Create volume. Okay, so then yeah, size is 30 GB. Okay, AP South 1A, snapshot nothing. Just give a name, data volume for EC2 instance 1. Okay, so this is the one that we have to do. So let me take a screenshot of this. I hope it is not too small. Insert pictures from file, desktop. So this, yeah. Click on create volume. Once the volume is created, okay, once the volume is created, select the volume. Okay, the state should change state should change to available. Select the volume and click on actions and attach volume. Okay, click on actions, attach volume. Okay, in the attach volume, select your public EC2 instance. Select public EC2 instance and then leave the devices as is. Okay, and then say attach. Click on attach. 8th. Okay, it's there. If you want, you can go to the EC2 instance and look at it. But the next step is going to be log in to putty to EC2 instance. Putty to public EC2 instance. Okay, then do ls blk. Okay, when you do ls blk, you should be able to see this new thing which has come up. Yeah, ls blk. Yeah, and putty. So that command is, you have to follow this article, right? So where sudo file -s dev, then sudo mkfs-t/dev/xvdf. So again, this xvdf depends on the command output of this. Okay, if it says xvdf, then use xvdf. If it is something else here, use that name here. Okay, I'll mention that. Use the name based on the output of lsblk command. Okay, so that's very important. Then create the file system, create and format the file system using this command. So once that is done, then sudo mk create a new folder in root, mount the 30 GB volume to /data using this command. Okay, once you mount it, then change directory to /data, cd/data, then create a new file in /data. Okay, once you create a new file in /data, file1.txt, just put some contents to that. So then come back to snapshots. Now I'll tell you how to create snapshots. So you have created a volume, now create snapshots. Okay, so this is create a volume. Then create snapshots. So for creating snapshots, go back to volumes. Yeah. So for this, go back to the volume and then select the volume and then hit on volume actions and say create snapshot. Okay. Go to E2 console, select volumes, select the new data volume. Actions, create snapshot. Okay. So create snapshot and give a description to it. Data volume snapshot. Okay, give a description to it. Data volume snapshot. Yeah. Okay, you will have the snapshot created in snapshots. Okay, snapshot will be created. Okay, snapshot is created. Then next step is select the go to snapshots. Select the snapshot. Click on actions and create volume. Create volume. Okay. And create volume. Select GP2 same. Don't change anything. Just keep it as is. But availability zone. Select the availability zone as availability. What's happening to my typing today? Select the availability zone to match the AZ of your second EC2 instance, which is AP South 1B in my case. Okay, in my case, you have to match it to where you created. Okay, and then say create volume, and then click on create volume. In fact, I didn't take a screenshot of it. No? I'll just do it. It's okay. South 1B. Just give a name tag to it. Volume EC2 instance 2. Okay, then go back to volumes. You will see that the second volume is created. I'll just copy this. Yeah, it's created. Okay, so now go to volumes 6. Go to volumes. Select the new volume. Create a volume for EC2 instance 2. And click actions. And click attach volume. Select the EC2 instance which is running, private EC2 instance which is running. Select the private EC2 instance. And then attach. Okay, so it's attached. The next one, so it's attached to your EC2 instance. Okay, so now if you go to your private EC2 instance, you go to storage. You will see 2 volumes attached to your EC2 instance. Okay, so now last step that you need to do is just repeat the steps repeat these steps. Okay, put it to private. Repeat all these steps here. Oops. Put it to private. Control C. Control C. Connect to private EC2 instance here, not public. Okay. Connect to private EC2 instance from your public EC2 instance based on our past assignments. Then follow the same lsblk, then cd to data, and then list files ls-l. You should be able to see the file 1.txt created in the EBS volume of EC2 public EC2 instance 1. Okay, that kind of completes this. Okay, I'm going to give this to all of you. So, okay, it got a slightly longer today. Sorry about that, but I think it was a good learning, correct?
No, in the second in the second part, we missed to remove that format file system.
Oh, is it? Okay. Oh, okay. Yes, correct. Sorry. I think we have to remove that. That's a good catch. Yes, absolutely. Okay, I'll also give the link. Okay. Yeah. Yeah, that's a good catch. Thanks, Hi Krishna. Otherwise, they would have struggled to see where did my file go. Okay, I'll also give the link. So please ignore this. Can you just delete this file that I just pasted? It's not possible to delete it. I just pasted the file in the chat. It's not possible to delete it now.
I don't think so. No. Sorry.
Okay. Okay, I'm also pasting that link here. Okay, so easy to create mount EBS volumes to Linux. So that's the fourth link that I've pasted in the document. Okay, to Linux. That is the fourth link that I've pasted. So please follow that also. Okay, ignore the first file that I sent. Please use this file. Okay. Okay. Yeah, I've updated that and I've sent the updated file. So please use this. And I will also give you the whiteboarding file just in case I have to refer to the concepts. Okay, yeah, I've given the whiteboarding PowerPoint as well. Okay, cool. So have fun with. Okay, finally, one last thing I forgot to mention. Okay, you have to clean it up. Okay, I'll also add that here. Okay, finally clean up. Clean up of EBS volumes. Okay, I'm adding that. Ignore this assignment file also. Use the one that I'm going to send as the last one, hopefully. The last and final. Sorry about that. Okay, so go to snapshots. First delete snapshot. Go to snapshots. Delete the snapshots. Click on delete. Select snapshot. Actions. Delete. Deletes the snapshots. After that, go to volumes. Okay. Go to the EC2 instance. Go to both the EC2 instances. Put T to both EC2 instances. T to both EC2 instances. CD slash. Okay, and then say sudo to mount slash data. And run the following commands. Both EC2 cd slash sudo umount slash data. Right, once that is done, then go to EC2 console and go to EBS volumes. EBS volumes. Select the volumes created. Data volumes, right? Yeah. Data volume EC2 instance 1, data volume EC2 instance 2. Click on actions. Click on
Sir, your screen is not visible, sir.
yeah, that's okay. I'm not sharing my screen. I'm only reading out. I'm just typing it. I'm going to send it across. Click on actions, detach volume. Click once detached. Click on actions, delete volume. Okay. Repeat 7 and 8 for the volumes that you created in this assignment. Don't delete the root volumes